record this session. So yesterday we have seen what is NoSQL and what is the need of NoSQL and benefits of the NoSQL. Okay. So today we'll see what are the different types are available for NoSQL. Okay. So generally we can categorize the NoSQL. Let me check who all joined. Okay. So generally we can categorize the NoSQL into 4 types. The one is key value database, and another one is document based database, and another one is column based and graph based. So these are the 4 general categories of the NoSQL technology. Okay. And okay. So this key value and column based and graph based, just you guys just will have some basic idea about it. We don't need to go in depth into it. We just it's enough to know what it is. Okay. So the key value database is basically React and Redis. The mostly industries are using Redis and React database. So it will have some key and key pair and the value. Okay, it will store the values with the key and the value. You can see here, right? The key is customer ID and the value is the object. Okay, so every single item in the database is stored as the key. Together, its value. So all items in the database is stored with the key and the corresponding value. So the Redis is basically called as in-memory database, and of course, if the operations, if the data is in the memory, then the speed and the process of the data will be faster than the other things, right? So the Redis use cases are like that. Some companies, right, like some aggregators, like whenever we get some transaction SMSs and all, right? So when we swipe something or some campaign running, say for example, if Amazon is running some campaign, we used to get some SMSs and all, right? So for that, consider a MySQL database is processing that, and if we bulk the load into MySQL, there will be a lot of queues may happen. So what the industry do is, I'm telling you one example, okay, one use case. So what the industry does is they first store the data into an in-memory database like Redis or MemSQL something. So whatever the databases will handle the things in the memory, they will use that. So the in-memory database performance will be high. So it will store the data with the key and the corresponding value. So all the data will be stored as an attribute together its value. So that is what called a key value database. And most widely used key value databases are React and Redis. And Redis database is very that is also easy to manage. Okay. I worked on Redis but not on React. So key value database pros very fast. As I told you, whatever the operations happening in the memory, obviously the speed and performance of the data processing will be very fast, and it's scalable. Scalable means I told you what is horizontal scaling and what is the vertical scaling. So we can horizontally distribute the nodes based on the keys, and simple data model. The data model is very easy, and consistency. It has eventual consistency and it has the fault tolerance. Uh, Cons, we cannot model more complex data structure. such as objects, because in memory databases, right, we cannot handle the large amount of data. That is one of the main cons, because memory we can have only the particular limit, right? More than that we cannot go beyond some thresholds, right? So that is the cons about the in-memory database. And document database, I'll come later to document database. Columnar database, okay. So the columnar database, this was developed based on the Google's big table paper, column oriented relational databases. The data stored in the columnar database is in the column and the value, okay. I think initially it was used by Facebook inbox search, the columnar database, and Cassandra is mostly used in the industries. So it looks like RDBMS, but it handles semi-structured. Means the RDBMS, what is the formation of the data storage? Just the data storage, it will store with the rows and columns, correct? But the columnar database, it has only columns and the values, columns and the values, columns and the values. Kind of, I'll tell you how it is. I'll show you. Okay. So one column family can have variable number of columns, and very sparse. Most still have null values. RDBMS versus column-based NoSQL. Query on multiple tables. RDBMS must fetch data from several places on disk and group together column families of those columns that are required by a query. So basically, the Cassandra, right? Cassandra is a multi-node database. See, for an Oracle, we can write only on the primary node, correct? We cannot perform any write operations on the Data guard is a concept of Oracle. We can say it's a secondary node, okay. So we cannot perform any write operations. Same like in MySQL, we call it as secondary node, slave, right? Replication slave, yeah. The slave node, we cannot perform any write operations in the slave node. It is only for read node. And similarly for PostgreSQL, we call the secondary node as standby. We cannot perform any write operations in the standby. We can perform only the read operations. But the Cassandra, right? If we have if we have n number of nodes, say for example, if we have 6 nodes, the 6 nodes will be able to receive the writes from the clusters, from the applications. So the 6 nodes, we can write the data any one of the nodes, node A, node B, or node C, node D, whatever the nodes we have, we can perform the writes in the particular node. So it's a multi-master technology, you can say. And the column-based database basically looks like this. So it has column name and column value. See, column name one, say for example, if it is a table name is um, uh, electronics, the mobile. Okay, mobile is the column name and the value, and the brand is the column name and the value, and the mobile price is the column name and the value, and the mobile configuration is the column name and the value. So that is how it's stored. The column name and the column value, column name, column value, column name, column value. But the RDBMS, the column name, row and columns. It is only columns, column wise it's stored. It's similar to the RDBMS, but not exactly like RDBMS. It's a NoSQL. And we call the language structured query language. We use SQL for RDBMS, right? To retrieve the data, structured query language. A columnar database, we call that as CQL, Cassandra query language. But the queries, right? It's similar to the RDBMS query, SQL queries. The columnar databases, the SQL language, right? Voice is not audible, guys.
Yes, sir, you are audible.
You are audible.
Okay, because Venu sent a message that he's not able to. Okay. So it stores like that way, right? And SQL language is Cassandra query language, similar to the SQL language. It is similar to like the select star from so and so table and insert into this table and values. Same like where clause, everything will be similar to, maybe slight modifications may be there, but it almost similar to the SQL language. So this is what the columnar database, um, and the graph database. So the graph database, see Apache Cassandra, the columnar database. One of the best examples for the columnar database is Apache Cassandra. Um, Now we have DataStax Cassandra as well. Apache Cassandra is the open source, and the DataStax Cassandra is the enterprise edition. Okay, and Cassandra was initially used by the Facebook inbox search. So these are main examples. The big table initially used by the Google's white paper, and then HBase and Hypertable and Cassandra and Peanuts. Peanuts is used by Yahoo. But widely used by industry columnar database is Cassandra. And the graph-based database. This is also one of the main NoSQL databases. Uh, Graph-based means the structure, right? The structure will look like a graph. Means it has some relationship between the records, between its data. Okay, so it was inspired by mathematical graph theory, G equal to EV. Okay, and it has the graph, the relationship between the nodes and records. I'll tell you what it is. See, there is a person, there is an author named John Lee. This author wrote the book of Tinker Taylor, whatever. Okay, and this book was purchased by this person, and this person also purchased a book of book named Our Man in Havana, and this book was written by this person. Okay, and this book was also purchased by this person. So it has kind of relationship between these things, right? The data, right? So it has some kind of graph model, it has some kind of relationship. This book was written by this person, and this book was purchased by this person, and this person also purchased another book, and this person also purchased this book, and this book was written by this person. So it has kind of graph model. So this is called graph based database, and most widely used in the industry is neo4j and the graphdb. So these are the most widely used databases in the graph-based database. I never got a chance to work on the graph-based database. Okay, and coming to document-based database, this is our main thing because MongoDB is a document-based database. Okay, uh, keep in mind, guys. So the RDBMS will store the data in the formation of rows and columns, and we have four different types of the NoSQL databases. One is key-based database, and another one is columnar database, and another one is graph-based database, and the last one is document-based database. Okay, so the graph key value based, it will have a key and the corresponding value, key pair and the corresponding value. And the columnar database, it has a column and value, column and the column value, column and the column value. The graph-based database, it has some relationship between the data. Okay, it has some connectivity, some hierarchical model. And finally the document based database, so all the data will be stored as a JSON document in the database. The document based database, the MongoDB is the document based database. It will store the data in a JSON format. Okay, and yeah, of course in the background it stores as a bson. So there are two terminologies. One is JSON, JavaScript object notation. I'll show you what is JSON and how it looks like. Okay, and bson is a binary format of JSON. Okay, so in the disk it will store as a bson, and when we query the data, it will show as a JSON format. Just JSON is nothing but JavaScript object notation. Okay, and it was inspired by Lotus Notes, and data model is collection of documents. So in RDBMS, guys who worked on SQL and MySQL and Oracle, you guys call the object as table, correct? The table and the record, right? So hereafter we are going to call the table as collection, and we are going to call the records as documents. Collection and documents. Okay, employee is a table, and the employee names and employee salary, whatever the data we call as a record. Employee is a table and the data is record. Here, employee is the collection and the data are called as documents. Got it? Tables and records, we simply replace collections and documents. So hereafter, whenever I use the word collection, it means, just imagine, it means table, and documents, it means it's a records. Okay, and this is what the JSON document, the name and the value. So the row, the columns, right? We call in RDBMS we call it as a columns, right? In NoSQL, in MongoDB, we are going to call this as a field. Okay, let me open Excel sheet. So field and the value. So this is the JSON document. This is what the JSON format. So this JSON format will have a field and the value. Name is the field and simply learn is the value. Address is the field and the address, this is the value. The courses is the field and these are the values. Okay, this is how the JSON document looks like. But in RDBMS, we'll call column and rows, right? Rows and columns, row 1, row 2, kind of. Okay. So document database example, Couchbase and MongoDB as the MongoDB are the most widely used in industries. And Couchbase, yeah, of course some companies are using Couchbase, but MongoDB is the number one NoSQL technology and number one document based database. The companies are mostly preferred and the companies are mostly used. Okay. So the MongoDB, the producer of the MongoDB is Tengen. And if you guys worked on the version 2.4 and 2.6 and all, the packages will come as the Tengen kind of. Okay. And the structured document stored in collections, each object has a primary key called object ID. I'll show you what is object ID. Each object, right, whatever the data we record, it will have a default object ID. So if we don't insert any object ID, it will assign a default object ID as an index, and the object ID is a primary key. Primary key, you know what is primary key. So for the freshers, primary key is nothing but it should not be zero and it should be unique. Okay, so this is what primary key. And yeah, Couchbase also document based database, and it also stores in the JSON based document, the JSON documents. Okay, I'll recall once. So we have 4 types. One is column key based and columnar based and document based and what else? Graph based. Okay, so key based, we call these as React and Redis as the best example for the key based, and document based MongoDB and CouchDB, and columnar based Cassandra and Bigtable, graph based Neo4j and GraphDB. Okay, and cap theorem. This is very important, guys. The cap theorem. So consistency, availability, and partition tolerance. Okay, what is consistency? Consistency means the data consistent means the data should be same, the data should be valid. Means if you are inserting something, if your application is inserting something, Okay, the customer is swiping something in the bank. Their initial initial balance is 1 lakh rupees, and they debit 10,000, and the remaining should be 9,000. Correct? I mean, 99. How much it is? 1 lakhs. If they 99,000, it should be 90,000, right? So whenever we check the balance, it should show us 90,000. After immediate we withdraw the amount, it should show us the 90,000. Means what happened in the background? It will perform some inserts and it will perform some deletes or updates, whatever. So after the deletion, updation, or insertion, the data should be consistent. Whenever we fetch the data, it should be consistent. The value should be the same in all the nodes. Say, for example, if I have node A, node B, node C, and if I am querying in the node A, and if I am querying in the node B, and if I am querying in the node C, all the data should be same in all the nodes. That is what called consistency, data consistency. Okay, and the availability means the database, the data nodes should be available at all time. So in some cases, if any one of the nodes was not reachable, I should be able to connect the other nodes. So there should not be any service interruption. So that is called availability. Okay, the reads, what is the end result? If the nodes are available, the reads and writes, I can always perform the reads and writes without any fail. If there is no nodes available, I cannot perform reads, right? If the database is down, I cannot perform any reads, right? See, this Excel sheet is running here. I'm running this in my laptop, this Excel sheet. Okay. If I want to find something, uh, what is the basic thing? I need to have this Excel sheet to be open. Without I open, if I shut down if I close this Excel sheet and if I am querying something, will I be able to do that? No, right? So if I want to type something, means typing means inserts. I'm inserting this, and when the this Excel sheet is closed, will I be able to type this? Will I be able to insert something? No, right? So this is called a database. If the database is down, if any one of the nodes are down, then we cannot perform any reads or any writes. So it should be available. That is called availability and the partition tolerance. So the partition tolerance, it should be available if any one of the nodes are down. It should be able to communicate during the network fail. Okay. So during the network fail, it should prevent the communications between the other nodes. So that is called partition tolerance. But in the industry, unfortunately, we cannot achieve all these three properties in any database. Whatever the database, we cannot achieve all these three together. Either it is Oracle or MySQL or Cassandra or NoSQL or MongoDB or whatever the PostgreSQL, whatever the database, we cannot achieve all these three at a time. So we should at least compromise any one of them. Okay. So the RDBMS, right? Traditional RDBMS prefers that is what. For any system being sharing a data, it is impossible to guarantee simultaneously all of these three properties. We cannot have most two of these three properties for any shared data system. Okay. And in RDBMS, either it leaves either C or A or C over A and B. I'll tell you which will come at that. So the consistency I told, strong consistency, it supports the acid property, and the weak consistency, basically available soft state eventual consistency. Okay. The consistency, each client, I mean availability, each client can always read and write. The partition tolerance, the system can continue to operate in the presence of network partitions. Okay, so this is the example. Availability, if we want to achieve availability and partition tolerance, we can go for DynamoDB, we can go for Cassandra, we can go for Couchbase, and we can go for React. The Cassandra I told, right? All the nodes are master. So any one of the nodes will be available. So, and we can have a multiple data center as well in the Cassandra. So if we have a 12 nodes, we can have 6 nodes in a data center and 6 nodes in another data center. So all the 12 nodes will be able to receive the writes and reads from the application. So the availability and the partition tolerance. If any one of the nodes are not available, then the other nodes will serve, right? Will serve for the applications. So there will not be any service interruptions. So if we want to achieve availability and partition tolerance, we can consider this one, Cassandra. So being a database architect, so if the application teams comes to you and if they are asking, hey, I have this kind of data, this is what my business need, and this is what my business flow, my business call, I need a database to be in place. Which database do you suggest for us? So when they come to you with this question, you should ask them first, okay, what is your need? What is your application gonna do? And are you okay to tolerate this? Are you okay to, your application should be available, or is it okay for you to have kind of little bit interruption? So all these questions you should raise to them. So based on that, you can decide which database you can go for them, go for their application. Okay. And the consistency and partition tolerance, we can, if we want to get the consistency and partition tolerance, we can go for mongodb. Okay. MongoDB and bigtable, hbase and redis, and availability and consistency. So guys, why the transactional processes I told you, right? OLTP, mostly companies are using RDBMSs for OLTP, like Oracle or MySQL or Postgres, whatever the RDBMS. The company goes for, I mean, for the OLTP, the company prefers always the RDBMS, because the RDBMS will have consistency. The Oracle is the number one consistent database in the database world. Okay. So if the application wants availability and the consistency, then they should go for kind of RDBMSs like MySQL or PostgreSQL or Vertica or Greenplum. Greenplum is nothing but a flavor of Postgres. Okay. And Vertica is again multi-node database, and it is similar to Cassandra, but not exactly. It has a multi-node multi-node configuration, the Vertica databases. Got it, guys? Okay, I'll pass on here for 5 minutes. Probably the call will disconnect in 5 minutes. I'll pass on here. You guys can ask if you have any questions.
Hello, sir. Hello.
Yeah, yeah. Who's there?
Sir, Rahul here.
Yeah,
Will
Raghu.
you please explain once again key value database? Key value database.
Okay, so the key value database is nothing but whatever the key records we store, right? So it stores as a keys, okay, and the key should have a key pair with it. So each key value database will have a value, okay, and it will store as a key and the value. See, the customer ID is the key and the object is the value, okay. So it will store as the keys. All the data, whatever it stores, that value stores as a key and it has some value, key and the value. Okay, and mostly the Redis is store the data, all the data in memory. Okay, so what will happen if you query based on the key? Every value has its own key. Okay, so it is easy to retrieve the data. And of course, the Redis is one of the best examples for the key value database, and it will store in the memory, in memory database. Actually, Redis is an kind of in memory database. Okay. Okay, I have started my instance. So this is AWS console, guys. So in the AWS console, we can create EC2 instances, and we can use that instance for our testing purpose. Like if you want to work something, like if you want to install MongoDB or MySQL or whatever the technology you want to practice, you can spin up an instance in AWS and you can use that.